No forget to subscribe, like and share this video. For this video, I go show you how to solve this stoichiometry question. 1 gram of calcium trioxocarbonate 4 was, that's CaCO3, was treated with excess 0.1 molar conc of HCl. Then there's a full stop there. At the end of the reaction, the acid still left unreacted required 25 centimeter cube of 0.1 molar conc sodium trioxocarbonate 4 to neutralize it. What is the volume of the original acid? So note the first question here starts from 1 gram of calcium trioxocarbonate 4 being treated with excess 0.1 molar conc of HCl. There's a full stop there. So the first step you take, you balance chemical equation. That is 2HCl plus calcium trioxocarbonate 4 CaCO3. This would give us calcium chloride 2 plus water H2O plus carbon 4 oxide CO2. So this is what we got, and this is a balanced chemical equation. So first step, balanced chemical equation. Second step, write out your mole ratio. So the mole ratio, this number here there's an invisible one, here, and here. So here's how we're going to do it. We'll say 2 ratio 1 ratio 1 ratio 1 ratio 1. So 2 ratio 1 ratio 1 ratio 1. Next step, we'll solve for the mole of HCl. Solve for the mole of HCl. And in solving for the mole of HCl, we use Sam's relation, which is what is given times what we want over what do we know from what is given. This becomes what is given here. We're given 1 gram of calcium trioxocarbonate 4 from our equation. So we'll say 1 times what do we want. We are solving for the mole of HCl. We'll make use of this one here from our equation, times 1 times 2 becomes 1 times 2 over what do we know from what is given. It's going to be the molar mass of calcium trioxocarbonate 4. Put it down here. Molar mass of calcium trioxocarbonate 4 is 100. So if you punch your calculator, 2 divided by 100, you get 0.02 mole. 0.02 mole of HCl. Now, once this is established, next we'll solve for the volume of HCl. The volume, and in solving for the volume of HCl, we'd say volume equals number of mole over the molar conc, which is, if you go back to our equation, you will notice that the molar conc of hydrogen chloride given here is 0.1. So it becomes, our mole is 0.02 over our molar conc is 0.1. So if you divide this, you arrive at 0.2 dm cube. But note, we need to convert this dm cube to cm cube. And how do we do that? We just need to multiply. So I'm going to multiply 0.2 times 1000. I will arrive at 200 cm cube. Cm cube. So this is the first volume for the first reaction between calcium trioxocarbonate 4, which is this one here, and HCl. Now, if you continue reading the equation, they say at the end of the reaction, the acid still left unreacted, meaning we still had excess HCl, required 25 centimeter cube of 0.1 molar conc sodium trisulcarbonate 4 to neutralize it. So we'd go again and balance another chemical equation and solve for the volume of the acid this time around, and that would be HCl HCl plus Na2CO3 Na2CO3. This would give us sodium chloride NaCl plus water plus carbon 4 oxide CO2. Now we need to balance this equation. If I apply 2 here, so it's going to be, if I put 2 here and I put 2 here, our equation is balanced. Next, to solve for the volume of the acid, we make use of the concentration of the acid times the volume of the acid over concentration of the base, volume of the base, equals the mole of the acid over the mole of the base. If I plug in our data, the concentration of our acid is, the concentration of our acid would go back to our equation. The concentration of our acid is 0.1 molar conc, and that of the base is also 0.1 molar conc, while the volume of the base is 25 centimeter cube. So we'll go back. If we make the volume of the acid subject here, we'll get VA. We'll go step by step. So we'll get CA VA NB, the mole of the base, equals the concentration of the base, the volume of the base, and the mole of the acid. So we divide all through by the concentration of the acid and the mole of the base, so we can isolate the volume of the acid. So this is the concentration of the acid, the mole of the base. This cancels this and this cancels this, and you are left with the volume of the acid equals concentration of the base, volume of the base, mole of the base over concentration of acid, mole of base. So what's the value of the concentration of the base? Is 0.1 times the volume of the base is 25 centimeter cube times the mole of the base from our equation here. The mole of the base from our equation here, the mole of the acid, sorry, from our equation here is 2. So we'll put 2 here over, what's the concentration of our acid is also 0.1, and what's the mole of the base is just 1. So if we go further, we punch our calculator, we would arrive at 0.1 times 25 times 2, you get 5 over 0.1 times 1 plus 0.1. So if you divide 0.1 over 5 divided by 0.1, you would get 50 centimeter cube cm cube. And so the total volume, which is what you're asked to solve for, total volume will be the first, let's go back and see, the total volume would be this 200 centimeter cube plus this 50 centimeter cube. So we get 200 plus 50, and your final answer will be 250 cm cube. Now let's check our options. So there you have it. The answer is 250 cm cube, option C. Next to the tax, I want you to try these ones out. These are just two questions. You solve these questions with similar method. These questions are just simulated questions of the first one that has been given to you. Once you're done solving and you would like to submit for assessment, so I would mark your work, click on the link in the description box. That will bring you to our WhatsApp group where you can actually submit, and I'll be there to correct you where necessary. Do not forget to share this video with your friends. I'll see you in the next video.